In this discussion, we're going to look at heating curves, their shape, and what do they mean. You can apply this discussion to cooling curves. It's just that it goes in the opposite direction. Okay, so let's look at the basic layout. The heating curve is basically a plot of temperature, and a lot of times on the x-axis they put time. And the reason that they do this is because typically when you're generating this heating curve, you are heating at a constant rate. And so as long as you're heating at a constant rate, then time is going to correlate to, let's get my pen going here, to energy added. So sometimes you'll see the x-axis as energy added, and other times you'll see it as time. But again, as long as we're heating at a constant rate, they're gonna be we can treat them as the same. Okay, so looking at the heating curve after you've gone through the lab, you'll see that in the lab, basically your heating curve is only going to have a small segment of this one. This is a full heating curve, and what this is showing is that we have a portion of the heating curve down here that represents a solid phase, and then we have the middle portion here that represents the liquid, and then an upper portion here that represents a gas. Okay, so these are areas where, as we are heating it, it is not undergoing a phase change. Okay, now if you remember from our previous discussion, when we are heating it and it's just changing temperature, we call that sensible heat. So the regions on this graph where we have an increase in temperature as we are adding energy, those are areas where we have sensible heat involved. Okay? All right, now, so what's going on the flat portions? Okay, one of the things you should have noticed in the lab is that when it was undergoing a phase change, that your data kind of held constant, your temperature held constant there. So here we are undergoing a phase change from a solid to a liquid. So at this point, right here on the heating curve, is where we're starting to melt. So it's all solid here, and it's melting as we go across, and then at this point right here, it's all liquid. So this is melting right there. Same thing up here. We hit this point on the curve, and it's liquid. All right, and as we add energy, okay, when we get to that point, it has all been converted into a gas. So this is boiling or vaporization, either one you can call it. Okay, it's fine. Okay, now, so what other information can we get off of this heating curve? Well, we can know from here, if I come across right there, that value right there is my melting point. Okay, and come across right here, that value is my boiling point. Okay, so the types of questions that I might ask you about this is I might give you a heating curve like this and say, is this the heating curve for water? And one of the things you can look at, remember we said that melting point and boiling point were characteristics of a substance, and so you could look at this and say, well, okay, here I'm melting at less than 60 degrees here, and I'm boiling at 90 degrees. So no, this would not be a heating curve for water. The other thing I want to point out is that a lot of times you'll see where the length of the melting line and the boiling line is different. Okay, now remember, the length of these lines is going to represent the amount of energy that it takes for that phase change to occur. And so one thing I want you to think about and talk about in your groups, and then if you can't come up with what you think is a good answer, then come see me. But I really want you to give some thought based on what you know about phase changes and the states of matter, and especially going back to our three big things that we're focusing on for particles: space, speed, and stickiness. Okay, focusing in on those things, think about why would that be the case, that the line representing boiling on a heating curve is typically longer than the line that represents melting. Okay, I think that would be a really good open response question on this unit test, just because that sort of question involves nearly everything we're looking at in this unit. So give it some thought and see if you can come up with a good answer for that.